Alright, let me get my compass and grid. Unfortunately, I don't have a camera or whatever set up for you to see what's on my page, but oh well. Follow along if you want, however you, I don't know. This is not very well thought out, honestly. And the structure that I'm learning, Euclid elements, isn't really extremely structured. I'm just looking at interesting stuff and then reading about it and then thinking. And that's just how I've been enjoying myself with this. Not not a very serious rigor thing. I just want to have some fun. So I think I'm roughly around. What was my last notes? It was Proposition 16. I think around that. Proposition 12, Proposition 16. So let's go 1.6, 1.7. Proposition 18, I think, was where I was left off. Alright. In any triangle, the greater side subtends the greater angle. Let's get this zoomed in for myself. Can you go up? There you go. So, in any triangle, the greater side subtends the greater angle. So the greater side, I think, would be AC, right? That sounds to me like a greater side. And subtends the greater angle. And so I would say the greater angle would probably obviously be ABC. So I guess that some connection BD would divide it in half, maybe? What that's saying? Is that, I mean, the logic for that would be like, we're just throwing out ideas first. I am not saying anything that clerical. We're just, so, I would say that the idea for this is because from the greater size perspective for a triangle, if there's a greater side, it has to be exposed to the greatest angle. Like it has to have that because it's the greatest side. So opposite of it is always the greatest angle. So I don't think that this is a very surprising proposition. Is this approach interesting to me? Because it just seems like that's kind of inherent to being the largest side, is that to be formed from the largest side, you need the largest angle. Otherwise, you aren't the largest side. Opposite. So, uh, okay. Um, for let ABC be a triangle having AC. So we start with an AC, ABC, AC, be the greatest. Also greater than BCA. Yeah. And ADB is external, which we know is the greater external angles, but BCB, BCD, BCD is as an angle, external and opposite angle. But ADB is equal to ABD, or yeah, ADB is equal to ABD. So that side there and there. Alright, thus ABD is also greater than ACB. ABD is also greater than ACB. ACB, yeah. Okay, let's go to 19. In any triangle, let's see what this diagram shows. Alright, so something that's this simple looking might be interesting. And in any triangle, the greater angle is subtended by the greater side. Okay, so from the perspective of the angle, it's subtended by the greater side. Uh, yes, or if not. So this is a if not conjecture, like, or if not, AC is certainly either equal to or less than AB. In fact, AC is not equal to AB, for then angle ADB, ABC I mean, is not, or for angle ABC would also have been equal to ACB, okay? But it is not, thus AC is not equal to AB, neither indeed is AC less than AB. For then angle ABC would also have been less than ACB, but that's not, but it is not. Thus AC is not less than AB, is not equal to AB either. Thus AC is greater than AB. Yeah, so similar. They kind of go in pairs right there. I mean, this is just showing like relationships, not really giving. I want to kind of get more sculpted, like I want to sculpt with a straight edge. I want more of a sculpting type of stuff. Things that give you specific numbers or divide in half or quarters or whatever, but I mean, we'll get there in time. In any triangle, the sum of two sides takes together in any possible way is greater than the remaining side. Hmm. The sum of two sides taken together in any possible way is greater than the remaining side. Yes. That is true. Why do I think that's true? How do I know? Other than like, because it has to be, it feels like a restriction of the angles, right? Like the angles force that to be. Hmm, I think. I know this is a thing, but I've never, man, why exactly is this true? Um, hmm. I mean, this is because of Pythagorean, like, or no, well, I guess is that too generic? No, I think it's kind of right? Pythagorean theorem. It's kind of a property of that, but it's kind of interrogating what that is. So then you got to think about like the boxes and the squares. Okay. So if this is an approach to think about it without thinking about the boxes and the squares, it kind of explains that Pythagorean theorem. I think that'd be pretty interesting. Okay, let's pursue it. Yeah, okay, so we have a reasoning, but I wanted to see what this reasoning is. So yeah, okay, let's continue. Let's do this one. For let ABC be a triangle, I say that ABC, the sum of two sides taken together in any possible way, is greater than the remaining side. So, we assume the sum of BA and AC is greater than BC. The sum of AB and BC, the sum of AB and BC then AC. AB, BC, then AC, and the sum of BC and CA, then AB. Or let BA have been drawn through the point D, and let AD. Okay, so we're drawing a triangle, a generic triangle. It doesn't seem like it has to be specified all that crazy. So I'm just gonna draw a simple little triangle, and with my straight edge, it doesn't seem to have any rules or restrictions or angles or whatever. So then we'll label that to be A. I'm gonna label them correctly and not, or not correctly, I just want to label them in the exact same way so I don't get confused. A, B, C. Alright. This is prop 10, 20. So prop 20, there. I say the triangle, ABC, yep. So A, sorry. Okay. For let AB have been drawn through the point D, and let AD. How do I interpret this from text? Let AD be made equal to AC. For let BA have been drawn through the point D, and then let AD be equal to CA. So I'm gonna measure the points of AC or CA, and I'm gonna then. Oh wait, I have a compass. Why the hell am I measuring? That's literally, where the hell is my compass? There it is. Yeah, I don't have to actually measure. Shit, I have a compass. That it does that automatically. Alright, so we're gonna put our compass on A and have that line up for C. And then I'm just gonna make a circle so that I can make a exact like continuation of the line to make a point D. Sorry, I don't know how to explain this with correct jargon to be interpreted correctly, but I don't know, I use the compass to draw a thing with the fixed radius that I needed instead of measuring it with units. I'm doing ambiguous unit of a radius. And then that did give me D all the way up there, and then it's telling me to close and make a join to C. Is that what I'm saying? Yeah, and then equal to CA, and then let DC have been joined. Yeah, DC, come on, District of Columbia, baby. I can't keep the ruler straight. There you are. Okay, I should have mirrored that um, triangle that they have on there better, because if you don't, you can sometimes completely miss it, but I'm already here. I messed up with my triangle. It's not the same shape. It's a little wonky, but that's okay. Therefore, since DA is equal to AC, the angle ADC is also equal to ACD, because they're wait, okay, so let's make a tick mark here, because AC and AD are equal. So let's have that as a little aside. AC is equal to AD. And from that information, you can deduce that the angle ADC, the angle ADC, this angle here, is equal to ACD, or ADC is equal to ACD, right? Okay, yeah. So that gives that this from AC being equal to DC, from the lengths, you can get the angles So then we're gonna draw. I'm just gonna draw it to myself. Sorry. ADC is gonna equal to the angle ACD, and so yeah, so I'm just blocking that out as that implies that with a little arrow. So thus BCD, the angle, thus angle BCD, BCD is this one. So from B, C, and D, O, the big ol', that's the biggest angle because B and D makes the largest thing. Um, is thus greater than, or yeah, so ADC, and since DCB is a triangle having the angle BCD greater than BDC. Wait, okay, let me go back. Prop 15, yep. So, thus BCD is greater than ADC. Is that true? I mean, yes, but let's actually point it out to ourselves. So, is greater than the angle um, ADC, angle ADC. Okay. And since DCB is a triangle, that's just a triangle having the angle BCD greater. So let's say the triangle of DCB. The triangle having an angle BCD. Yeah, the large one has. I guess I'll just say has large angle DCB. It has the big old thing. Is a triangle having the angle is greater than BDC, clearly, which is greater than the angle BCD. BCD, BCB. I mean, BCD and DCB are the same angle. So I don't understand there what is trying to be said. And the greater angle subtends the greater side, DV. Okay. Thus is greater than BC, which is true, and but DA, BC, but DA is equal to AC. The sum of BA and AC is greater than BC. Greater than, well, yeah, because it's just self added, right? Is that what it's saying? It's greater than, so it equals AC. Thus the sum of BA and AC is greater than BC. Yeah. Similar, we can show that the sum of AB and BC is also greater than CA. Yes, because it's the same reasoning. It's just the other leg. Thus, in any triangle, the sum of two sides taken into together in any possible way is greater than the. Okay, I see that now because the extension that we made from to get to point D in the first place to reach this point is the same thing here. And so if we go and add this to any of these legs, we know that this leg is also the same thing, these legs. So this is showing that this is a subtension or whatever, it's just saying because of subtension. How do I pull this? Let me think again. Very close. Let's just write it down because the sum of, okay, let's just show the sum symbol. Sum of BA, and AC is greater than BC. BA, AC, yes, and then BC. Yes, okay. So these are matching. You go here, it's larger than this. You go, these are matching. You go here, this is larger than that. These two, and that's larger than this. Similarly, yeah, my brain is a little fried. Why I can't do addition? Or I can't hold these names in my head. I have to write them down. Alright. AB, BC is also greater than CA. So AB, BC, yes, okay. Yeah, I don't, sorry. That's, yeah. So that is greater than this, and this is greater than this. And then the sum of BC and CA, BC and CA is also greater than CA. Or wait, the AB, or no, is AB. So yeah, this is also greater than that. These two, that and that line. So therefore, and that is a different way of thinking about why the sum of two sides taken in any way is greater than the other side that forms a triangle. Okay, that was interesting. Interesting kind of thought because it feels like a, I guess, concatenating, I don't know, kind of thing where you demonstrate its ability by adding a length, a known length, and then just saying, hey, that known length addition is larger than your other lengths. And then that's kind of how that goes, right? Alright, continuing on. What is this? That's like something crazy right here. If two internal straight lines are constructed on one of the sides of a triangle from its ends, the constructed straight lines will be less than the two remaining sides of the triangle, but will encompass a greater angle. Greater angle. Well, because they okay, so they would encompass a greater angle because they're forming of shorter sides, and greater angle means that the sides that they are not encompassing would be the largest side, which is opposite of it. Is that kind of the line that I'm thinking on? If two internal straight lines are constructed on one of the sides of a triangle, what does that mean? On one of the sides of the triangle from its ends. I don't really even know what that means. Prop 21. Alright, what's up? Okay. Yeah, I don't really know what this is saying. For let the two internal straight lines, so BD and DC are the internal straight lines. On one side of BC of the triangle ABD or ABC. So we start with from its ends B and C respectively. I say that BD and DC are less than the sum of the two remaining sides of the triangle BA and DC. Wait, what? No, the triangle BA and AC. Yeah, I was like, wait, I'm reading the wrong part. Um, for angle BDC greater than BAC. Yeah, okay, now I get it. Because this angle has to expand. If you're gonna shorten these things, this angle has to compensate by getting larger. You know, it's like opening a mouth, I guess. Like when you stretch your mouth bits and I guess you're going forward, you get your flesh gets a little stretched and your folds gather and strain, and then you relax and your angle decreases. This is the mouth. This is the mouth one. This is how I'm, yeah, this is the mouth, and this is how eating works. Um, Euclid told me so himself in Greek, which you think I was reading this section. I'm actually reading this part the whole time. This is for your convenience. For let BD drawn through to E. Okay, is there any restrictions on what the inner thing is, or is it just an arbitrary line? Like two interlines, whatever. It doesn't say anything about their construction that's like restrictive. Greater than the right side. In triangle ABE, the sum of the sides, two sides AB and AE is thus greater than BE. Yeah, BE. This one, this one is greater than that for sure. Right? Is that what it said? APE is the sum of the two lines AB and AE. AB, AE. Oh, we're actually looking at this triangle. Well, AB, AE is greater than BE. But EC have been added to both. EC been added to both. Okay. Um, my phone notification. That's nothing that matters. Gonna I drank up some tea. Very cool. Pretty swag. It's pretty alright. All nice. Anyway, let's go. Uh, yeah, two sides AB and AE that's greater than BE. Okay, yeah. Um, let EC have been added to both, thus the sum of AB and AC is greater than the sum of BE and EC. Again, since it's a triangle CED. Okay. Added to both thus. Um, is there any more rules for how to actually draw this thing down, or no? Or we just we're just in deduction mode? Okay, I think that's it. So let's take these instructions, which are very light and kind of ambiguous to me, to my sensibilities. Maybe I'm just stupid, which is fair enough. I'm gonna start with a triangle of ABC. I'm just gonna map that little diagram as best as I can, and go draw that down. Alright, that's my ABC. Let's mark it down. A, B, C. Then, from its ends, B and C respectively, I say that BD and DC. So I think I just pick a point that seems kind of close to AC, right? I don't think there's anything that crazy about it. Two remaining sides of the triangle, BA and AC, but compass and angle BDC greater than BAC. Blood alcohol. Yeah. Yeah, I can't help myself. I'm a child on the inside. So I'm just gonna pick a point D that's just a little bit below A. I don't think it matters. I'm just gonna call that D. And then I'm gonna take a straight edge from B to D to that line to the AC. And then I'm just gonna do the D to make a line connecting D to C. And that is the beautiful construction. And from that, we can go down, say, a tick, then we gotta write down our tick marks and equal signs and all that type of stuff. So, so BD and DC are less than the sum of two. So, remaining sides of the triangle BA and AC. So encompass an angle greater than BAC. So we say that the angle BDC is greater than BAC. So let's write that down. BD, if I write the symbols in the right way, that's awesome. BDC is greater than the angle of BAC. That's what we're throwing down as our idea. Um, Two sides greater than the right side, yep. The triangle ABE, let's look at that now. Oh, let's also write down our E. So ABE, okay, let's look at that triangle. Saw two sides, AB and AE. So AB plus AE is greater than obviously BE because we just looked at that from postulate 20. Um, and where are we at? Yeah, and then we're here. Let EC have been added to both. EC, okay, this length of BA and AC is greater than the sum of BE and EC. So BA and plus, or wait, the sum of, yeah, BA plus AC, BA and AC, that seems like it's the greatest thing, is greater than pretty much almost anything here. Uh, BE and EC, BE and, I don't think that means added together, it just means individually, BE and EC. So BA AC is greater than BE because BE is already less than BA and EC. So those components in association with each other, E is a shortening of BA and BC. Okay, respectively, actually, yeah. Uh, AC, then we have this triangle CED. Let's look at that. CED. Oh, it's the other sliver. And then from there, I guess we're doing the exact same thing again, where, I mean, CE and ED together is greater than ED. Yeah, and then blah 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 blah. Okay. And opposite angles. Let's look at the angled part now. That's the more interesting bits. But yeah, we're just doing the foundational work. Yeah, this T is good. It's definitely all good. Anyway, um, again, since in any triangle the external angle is greater than the internal in opposite angles, Prop 116. Same BDC is thus greater than CED. Yes. Accordingly, for the same reason, the external angle CEB, yeah, that is also an external angle from that triangle. of EDC, right? Or CDE is triangle. Yeah, yeah, EDC, CD, it's the same triangle, I just said it differently. Um, and then CB has another external angle, true. Of the triangle ABE, yeah. But BDC was shown to be greater than CEB, yeah. Thus, BDC is much greater than BAC. And then so it follows if two internal straight lines are constructed on one of the sides of a triangle from its ends, the constructed straight lines are less than the two remaining sides of the triangle, but encompass a greater angle, which is the very thing we were trying to show. It's a interesting one from that approach. How do I approach this differently? No, I mean like looking at the external angles or whatever and being like, by that difference, by that how that there's like a bigger one. There's these external angles are always the bigger ones. When you make a arbitrary point from the ends of one of the sides of a triangle. Hmm. Yeah, I mean, I guess I would look at the case of like a very, very minor change, like the limit of from like basically almost a perfect replica of the triangle, but you just slightly nudge. So let's say like here we have the triangle here. I would say like we could just make a copy of this triangle and then we make a very, very slight nudge from A to push it inward into the inner area of the triangle, and then you would observe what would happen to the lengths of AB and AC. And as you nudge it and 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 nudge it more from the, with the restriction that you can only, project off of this one side from B, C, these ends, you get a transformation or something of that sort where the angle just increases and increases and increases and the lengths get shorter and shorter and shorter, and it doesn't really matter how you push those, like the node of A around in this big old box. Like it doesn't, you can position it anywhere, and the angle will increase and the lengths will decrease. Overall, their sum will decrease because obviously you could go here and go along this line, and AC would increase as BD would decrease. But overall, like it'd be less length because by definition, right? It would be like by definition of how a triangle is even constructed. You can't, pack in more length, or else triangulation would not be a thing, and this beautiful shape would not exist. Woo wee! Cause we got some circles, and we're gonna play around with some radii. I think. Prop 22. Yippee, baby, 22. No, people are missing out. They're missing out. All right. Bitter. Sorry. Prop 22. Construct a triangle from three straight lines which are equal to three given straight lines. What? It is necessary for the sum of two of the straight lines taken together in any possible way to be greater than the remaining one. Yeah, okay. I don't see that as that interesting, because we've already been through this. Okay. Proposition 23. Sorry if that was your favorite proposition. I'll get back to that later. Of course I will. Alright, I'm lying, probably, most likely. To construct a rectilinear angle equal to a given rectilinear angle at a given point on a given straight line. What? To construct a rectilinear angle equal to a given rectilinear angle at a given point on a given straight line. What is a rectilinear angle? I guess we'll just keep reading. So you got um, two lines and then just an arbitrary. Hmm. I don't think I understand. Let AB be the given straight line. So we start with AB. A, the given point on it, and DCE be the given rectilinear angle. DCB, DCE. Okay. So it is required to construct a rectilinear angle equal to the given rectilinear angle, DCE, at the given point A. Okay, so this is telling me how to make any arbitrary whatever angles be transplanted onto a specific point, right? Like this is like copy pasting type of like copying certain information, putting it down somewhere else type of manipulation. Is that what I'm reading? Um, okay. Let the points D and E have been taken at random. Okay. So we were starting. Okay. At random on each of the straight lines, BD and CE respectively. Okay. And let DE have been joined, and let the triangle AFG have been constructed from three straight lines which are equal to CD, DE, and CD, DE, and CE such that CD, DE, CD, DE, CE such that CD is equal to AF, CE to AG, and further DE to FG. Okay, so that's how you transplant it, because you literally are just using compass to capture the exact radii. Okay, cool. I mean, yeah, I would do it. I don't think it wouldn't. Therefore, since two straight lines D and C are equal to two straight lines FAAG respectively, and the base D is equal to the thing, then the angle is equal. Okay, so yeah, that's how you do it. At the given point A on a given straight line AB. Alright, I mean, I guess I think I understand what this is saying, so let's just go through it because it seems like a more just like a practice that isn't hard to do, but very useful. So we start with a given line AB, right? So let's just pick this as a straight line. Okay, and then we are given, and then we're gonna have A be the point on it. So put A right here. Not anything too complicated. Then what is required? BCE. So let's just, it doesn't say that there's any restriction on the angles, so I'm just gonna make up, draw two lines randomly and just say that that's my angle that we want to transplant. Call that angle C from lines D and E. And let the points D and E have been taken at random, so I'm just gonna shuffle my compass because I think I need to capture these angle information. And then I just plop it down on C and then draw it here. 3, then I'm just gonna shuffle my compass a little bit. So they're different and they're random. And then join them. Cool. And then let the triangle AFG have been constructed from 3 straight lines, which are equal to CD, DE, and CF, respectively. So I'm gonna take my compass and go here, do that, try to match it from where I did. Then I'm gonna draw a circle-ish shape around A. I mean, it doesn't need, the circle doesn't need to be behind A at all. So we're just gonna draw in front of A. And then on A, we're gonna take the angle, or take the length of E, and then from it, yep, so we captured point E. Then we go back to A and just make another circle with this one. You know, stupid is that's not how you do that. I just made two circles that are slightly different sized around A. This is my point about practicing this one because it seems very useful and simple, but clearly I did something wrong. Let the point A. So GD is equal to C. I don't know, let's just draw, I think that's equal. And then, oh wait, because there's just a line, then I can see where the radius that I made from the point E information. I can then draw, like I can just say that that's point F, and then I can draw from point F to the line that A is on. Oh, that's neat. Okay, so I didn't do it wrong, I don't think. I saved it, for being very dramatic. I saved it. I can't draw correctly with a ruler, but let's do that again. You don't even see me failing to draw with a ruler. Okay. And that should be the same angle as C now, I think. That's just been transplanted. Because the angle, let's just check the lengths, make sure that I didn't mess up because I think I didn't. No, that's good. And the length of this is here, and that's also good. Okay, so yeah, and that's how you do that. You draw two circles based off of this information here, right? Oh, wait. Um, the length of D and E should be equal, and if they're not, then I messed up. So, they're not equal. I messed up. Hmm. That's okay. You draw three circles. You draw three circles, and the third circle has to be the from a point that you formed from one of your previous circles. That makes a lot more sense. Now that looks a lot closer to the actual angle. Hmm. No, I'm so close. I'm so close to figuring this out. It's not hard, or it's not that complicated. It's just there's just an order to do things, and I messed up. Alright, let's try again. Yeah, let's just another straight line. Call that A. Call the other end B. Construct a thingy of just an angle thing. That's gonna be nice and simple. Maybe I should actually measure out an angle for this one and like get 45 degrees or something like that. Nah, nah, I don't want to do that anymore. I'm just gonna be arbitrary. Alright, and then okay, D, pick a random point there. Put that needle precisely right where I need it. Yay, I made D, point D. And then let's shift our compass down a little bit, and then make point E. Then let's draw the lengths that we need, and then, yep. So how do I, hmm. So we're, from one length of thing, I have to capture that information. I think I just go, There we are. Let me go ahead and capture this information from D, the same length from DC. Let's throw that on A and then see where they collide with. They don't collide ever. Because obviously they don't collide ever. They're on the exact same point. Okay, so let's go to the next point that's just been formed. See if that makes. Yeah, they collide right here. Okay. Right? Collide up here. Should it be that one or should it be... you know what? I'm just gonna draw two circles, whatever, and we'll see which one works. Because, yeah, I'm just kind of messing around. I probably could just read the book and it'll probably tell me, but I'm drawing doodles, and it's fun. Okay. And then I'm gonna take this one, this length again, and then from here, we're gonna draw a circle, and I don't know what to do with this again. Okay, well, we're gonna take the smaller length and then draw another circle. Maybe that will be... I mean, you can't go that far off from these simple instructions, you know? I'm trying to go as off the deep end as possible. What am I doing? That's pretty cool. That feels like a triangle shape that I should be doing because it kind of ends right there at A, like a satisfying level. So I could just go like here. Hmm. No, well, it's not the goal at all. I don't understand. How am I having this much issue with this? Come on. Yeah, I don't, man. Hmm. This is so, um, um, I failed again somehow. So I'm gonna just do it again, and then I'm gonna read slower and do it again. So, gonna just draw another line, making A and B. You're not missing much by not seeing by not seeing the failures that I'm drawing. All right, I promise you that. Okay, so straight line AB. Let the point D and E have been taken at random, and let D have been joined. And let the triangle AFG have been constructed from three straight lines which are equal to CD, DE, and CE, such that CD is equal to AF. So, yep, CD is equal to AF, and FG is equal, let's just write that, sorry. CD equal to AF. F, or da 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 da, DE is equal to F, what's G? I haven't even got to writing G a single time successfully. So I have difficulty finding G, but ah, you dirty dog. CE is equal to CE is okay, and then AG. So again, that G. How do I get to G? Um, the two straight lines DC and CE are equal to two straight lines FA and AG respectively, and the base DE is equal to the base FG. The angle DCE is equal to the angle FHE. You're killing me. Yeah, DCE is equal to the angle FHE. DCE is equal to the angle FAG. And, yeah, so we're still, okay. So that's, okay. CD, yeah, CD is equal to AF. Um, so that, to me, just means, like, just draw a circle, whatever. Like, it doesn't matter. And you get a range. So let's just pick one and say that that's that. And be like, okay, we're done. We don't need to overcomplicate it and confuse ourselves with that big range of stuff. And then I want to find, I want to, okay, so we're just gonna say that that's F, point F now. And now I want a F that hits a point E. So we're gonna take DE as our length. And then we're gonna be quite choosy with this length and say that it's gonna have to contact the line segment because right no does that make sense? Okay, and then I should just be able to and then I say that that's the G. So I think that's how you find where to put G in its right spot. So I can just put A, connect A to F, and then I can connect F to G, and therefore this should create. So let's check. So A to G should be equal to A, C to E, but it shouldn't. There's no reason why it would be because this is an arbitrary line made with A and B. So obviously that's not gonna equal A or CE. So we need to make, we did not find where G is supposed to be. We need to, there has to only be one point because it's a triangle. Of course there has to be only one point that satisfies, and that's where G is found, right? Picked F arbitrarily. Let's capture the information from D to E, and then we're gonna, okay, and then we have to find where that lines up. Is there any reason that... Okay, let's use this arbitrary line as our guide. And that will tell us where F has to be. I think F has to be the thing that actually moves around. How does this work? How do you make a triangle? What am I doing? I'm doing this... Okay, so F can't be an arbitrary point, because it has to be this length. So is there a place where all these lengths line up? Is it stupidly precise, and I'm just not good? Because I don't understand. I'm trying to use these lengths and making associated radiuses, and then... Okay. So we're deleting point F. We're going backwards, but going backwards is forward progress and understanding. Alright? So sometimes you're just drawing circles on a piece of paper over and over and over again until you finally have enough and give up, honestly. And then you pick it up later. So, hmm, where are you? So this is the C to D. C to D is this one. So that's the C to D one. So let's just label this as the thing that can find F. This finds F, and this finds E. Okay? So, and we have a straight line that we can't diverge off, because if we diverge off the straight line, then the whole exercise makes no sense to do in the first place, because we're trying to arbitrarily pick on that straight line that angle we want it represented on it. So if you don't use it, then you, you, you know, you're not using it. You're not doing this whole exercise. You fail. Go back to class. All right, and then um, okay. So we have two options for that straight line. We have option here. No, wait, we don't have two options. We only have one option here, and that's where this circle comes from. Okay, so if I understand, we find F where the radius of D and E meets the radius of C and D, and that's where F is. So that's this point right here, and then we find E on a straight line given, and it's right here. Right? No. No. C and E. C and E is now the length. You're so funny. These these lengths being slightly different and so similar. Okay, no, actually, wait, that's very close. Okay. Um, that's not the end of the world. That just means I slightly adjust my compass. because my compass was wrong and I wrote the wrong radius basically. I just didn't adjust my compass correctly. Um, so that's awesome. Okay, and now let's draw it. And this should be the exact same triangle. Honestly, it's not hard, it's just dense with information that you have to actually like take into account because you're balancing like 6 different points or whatever. Alright, and then we can look and say, hey, alright, let's take a cursory glance and say, hey, does that look, it does, that angle looks about right with the same side lengths and stuff, right? Does it have the same side lengths? Almost, but that could be user error, honestly. I don't think it's off by such a degree that, um, okay, so that's how you do it. So to recap, um, you take you take this straight line, and then you have a reference angle C. You pick arbitrary whatever length. This length here, you create a circle with that radius. Then you find, I think it was, yeah, I think you find this one. Then you find this and say, okay, here's a radius here. And you make a circle around this point, because if you put it around this point, you just make 2 circles that don't intersect with each other. And then that will give you a point over here, that's point D. And then from point D, you use this length here, and that will give you a point on this arbitrary line for you to associate it with. And then you'll be able to successfully recreate the triangle from reference, from balancing, drawing 3 circles, because the third circle is necessary, right? Or could I get away with 2? Could I get away with 2? You cannot get away with 2, no. You have to draw 3, for sure. Because, yeah, so you have to draw this one you draw this one from here, then you draw this one from here, that gives you this point, and from this you draw that one, and intersect with the line, and that gives you the third point here. Right? I don't know, I literally just did it, and I don't think I'm great. Wow, that one took a lot. That was a lot of energy. And I ran out of tea. Okay, I didn't run out of tea, but this is gonna be the last sip. It went cold. That's how long. Alright. So yeah, that's Prop 23. I think that's a good blah 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 bit. So I'm just gonna put some highlighter here. Never mind, right? Draw. Boom. Not what I wanted. Control Z. There we are. And then I'm just gonna save that. Uh, and put that into my documents and enjoy that. Just save it over, overwrite it, yeah. Okay. That's enough. It wasn't hard, it's just, I don't know, I'm done, you know, you know exactly what I mean from my feeling. Um, if you, for some, you know, thank you for joining me on my studies and whatnot. That it makes me go a little loopy, it makes me go a little crazy. Um, hopefully I helped you stay a little loopy and stay a little crazy as well. Um, I I I don't know. Am I done, or am I just doing something else? I mean, I don't know what else I'll be doing right now.